Technical report writing is a skill set that every engineer should have. We need this skill set because we need to be able to communicate effectively to our peers, subordinates, and clients. We also need to document, we have to document reports, technical reports, problems we've solved, work we've done, end of work reports, white papers, progresses made. So it's very important that every engineer has and masters this skill set. As we pause to think what other reasons why we need to be able to write effectively as engineers, let's click the subscribe button below as we proceed. Good day, everyone. My name is Ugokoli. Today we'll be speaking on writing excellent centered technical reports. So note the keywords: excellent, problem centered, and should be technical. So we will be discussing the topic with the following outline. We'll be introducing the topic, look at the background, look at generic technical outlines, look at the do's and don'ts require, and also the required skills that we need as engineers. Then we'll go ahead to conclude. So that brings us to the next big question: why? Why do we have to be competent in technical writing? There are a lot of reasons why we should be. There has to be effective communication. We need to document our work. Working with a team, you need to be able to communicate. Getting from problem to solution, there will be communication in between. Even in between where you have the analysis, there needs to be some sort of communication and documentation. Collaborating with your team and clients, there will be communication. You need to be able to have very good technical writing skills to pass on information. In your career advancement, there is no way you can advance in your career as you should without being able to communicate effectively. Knowledge transfer, that can happen without good communication. In your risk mitigation, you need to be able to identify most of these risks. You need to be able to curb these risks, and there is no way you can do that effectively without communication and technical writing skills. For you to be very innovative, you have to be a very, very concise person. You have to be somebody who is detailed, and there is no way you can be detailed without good writing skills, without good communications. To buttress the last slide, on this slide, I have 16 papers that I wrote in 12 years of my career. Some of these papers are related, some of them are sequels to an earlier paper. For example, looking at these two papers, the first one written in 20 to the next paper, and that helped with very, very decent abandonment of that exploration well that you see. That's the SP paper 193490. The next two set of papers speaks on hydraulics, lessons learned, and things we did in and documented in this paper. Those were the lessons and knowledge transfer that we took in writing the next paper. That these two papers I wrote in the same year, and you can see one has to do with the intervention challenges, subsea intervention challenges, and one has to do with cost estimation. Of course, we had looked at the potential challenges that we will encounter getting into that well, and we had looked at the associated timing. So, moving still deep into the background, before writing papers, before writing a sound technical paper, you need to understand what the problem is. So, what is the problem? What are you trying to solve? What is the impact of the problem? If you're able to understand the impact of the problem, how that problem affects, is it perhaps, does it affect the capex of the operation? Does it affect the opex of the operation? Does it have to do with safety? Does it have to do with life? I mean, perhaps a potential fatality while doing operations. If you get a solution to this problem and you're able to communicate it succinctly, it is for the best of the whole team. What do you want your readers to understand? People who are reading the information you are trying to pass across, they need to understand what you're putting down. So you have to have that in your mind while you're writing that paper. how does your paper differ from others? So to rephrase that question, what is new? It is very possible there's a paper that is synonymous to it, that looks like it, that perhaps addresses the same problem. So you need to be able to be clear what exactly is new. What is it that is new that you're bringing to the table? What's different about your own solution that needs to be clearly highlighted in the paper? What are the specific lessons to be learned and solution? It's another way of saying what is new. What's the impact of your research? Again, addresses the second question. If you if you're able to understand the impact of the problem, you would definitely know the impact of your research. For example, perhaps you saved $50 million, or you saved, or you made the operation move faster than normal, or you reassess the field development project and looked for and found a way to do it, perhaps in a safer manner. So that needs to be clear and communicated properly in your paper. Who are your target audience, and when they read, what information do you want them to get? What information do you want them to understand? So on this next slide, we have what the outline of what you should have. So you should have a title, the abstract. You should introduce the topic, look at the basic theory and definition so that people can understand before they get in. Talk about if there are any equipment and processes that should be discussed. Then look at the data and results that were used to solve the problem, or that you gathered while solving the problem. Then you conclude, make acknowledgements, and make sure you put down your references if there were any. The do's and don'ts: make sure you organize your thoughts, use simple sentences, use very common language. Don't try to sound very smart. Don't be verbose. Um, ensure the paper is technically sound. Read it again and again. Ensure there are no typos, and please get a second pair of eyes. This is very important. You're writing this paper for the audience anyway. You're writing this paper to be rolled out to people to read. Now, if you write this paper and keep it to yourself, you don't push it out to people to help to have a second pair of eyes look at it, then I honestly don't see any point. Get as much people as you can on it. Let them read, get their ideas, and it will all, trust me, it will only make it a better paper. Use any sales speech, um, and don't be verbose. Use very simple words, already mentioned in your do's. Your required social skills should be very enthusiastic. I mean, work done without enthusiasm can be very bland. You need to be excited about what you're doing. You need to have very good research skills, know where to find some things you can get from people. Some You need to know sites, you need to know what books to reference. Of course, the main topic, you should have very good technical report writing skills and be very open-minded. There are two um, things I've mentioned here: the Dunning-Kruger's effect. We'll talk about it on the next slide, and most especially, be Jon Snow. I corrected that. Be Socrates. Know that you know nothing. What we mean by that is, when you believe you know nothing, you have an open mind, and you will always want to ask questions. You always believe that you're not that you're not smart, but you have the ability to learn, unlearn, and relearn. So that's very, very important. So speaking of the Dunning-Kruger's effect, it's just a way for us to address that thing in us that makes us believe that we know it all. When you learn something new, look, on the x-axis we have competence, on the y-axis you have confidence. There's a very invisible line here under the competence. On the y-axis, I would like to call time, because this actually increases with time. So when you learn something new, your confidence goes way up, and you actually think you've learned it all. You actually think you know it all. So you stay up here. But when it's time to solve problems, or when you really get deep into the meat of it, you find out that you don't actually know as much as you think, and your confidence comes crashing. then your competence. But trust me, when that happens, for you to already understand that you don't know as much as you think you do, your competence is actually increasing. Trust me. Sorry, your competence, not your confidence. Your competence is actually increasing. But guess what? When you stay on track and keep developing yourself, keep doing the necessary work, reading books, getting yourself up there theoretically and also practically. And as you're doing that, you see that your confidence will start to pick back up because you're picking up the things that you didn't know from here to here. And at that point, you're beginning to get not just competent, you're also becoming confident because you know, as in this is the confidence that comes from real competence, not false competence that you had in the initial at the beginning. So that's pretty much what this graph means. So what it's trying to say is keep an open mind. When you learn something, know there's still a lot to learn, and you keep telling yourself that you don't know it all. So it's just buttressing um, Socrates. So this is just another cartoon elucidating on what we just showed. So you see this guy, he reads a topic, and all of a sudden he's like, I know it all, and he tosses away the book. But in between, he's beginning to find out that there is more that he should know. But guess what? He doesn't lose hope. Even though he's bewildered, he still goes ahead to study, and he's getting that smile back on. And ladies and gentlemen, at the end of it, he is now confident because the confidence is spiking back up because he now has the knowledge which he has grown with time. So on the other slide, we had competence. Here we have knowledge. I mean, we all agree that they are synonymous. So to end this topic, I'll just be um, glancing through of two of my papers. The first paper, 178477, improving hydraulic cement isolation for subsea operations. So the this is a cement bond log. The cement bond log you see to your left is from one of our wells, and if you agree, we see how bad this cement bond log is. It was really bad. We're having issues with poor hydraulic isolation, and we didn't know why that was happening. So we went ahead, did very thorough research, and found out what the reasons were, and went ahead to correct the problem. I'll be presenting that sometime, but you can before then you can go ahead and pick up this paper and read it up. And after that work was done, ladies and gentlemen, this is what we now have, and since then our spendball logs have been excellent. We've been having excellent isolations. Second paper I'd like to discuss is 178478, optimizing hydraulics for drilling operations. Now for this particular well, the problem was we had a lot of depleted reservoirs. It was it's a brown field. We had a lot of depleted reservoirs. So we found, I mean, with depleted reservoirs, you have the formation loses its cementation, and you have start having subsidence, and it loses. I mean, it's fracture gradient reduces. That's the minimal horizontal stress reduces. So we found out that whenever we're drilling and the ECD goes up, we begin to have losses because of that. So we needed to model our hydraulics in such a way that at every point in time we had a grip on our equivalent circulating density and standpipe pressures. So what did we do? We took all the models, and just to mention, this modeling was done with Paradigm Sys Drill, the well engineering software we're using at the time. So we took all the models, the Power Law, Bingham Plastic, Robertson Steels, Herschel Buckley's, and we modeled the well at drilling to TD with the particular mod width that we're going to be using. And for each of these models, for Power Law, we had 11.47, Bingham, we had 11.72, Robertson Steels, we had 11.35, Herschel Buckley, we had 11.37. And these are their corresponding standpipe pressures. When we went ahead to drill, that's the actual, these were the values we had. For ECD, we had 11.67, and for standpipe pressure, we had 3,800 psi. If you look at the standpipe pressure, you see that it's very close to that of the Power Law. And if you look at the ECD, you see that, excuse me, you see that it's very close to the Bingham plastic. And we started using this and matching while we drilled other wells. And ladies and gentlemen, we were always close. And that way, when we went to, as engineers, when we modeled before we went to drill the well, we were, I can say, almost sure what the ECD and standby pressures were going to be. But take note, we had to pay very good attention to other rheological parameters like the yield point, the plastic viscosity, the low end rheology, and all that. We had to pay very good attention to be sure that what we modeled with, that at the end of the day, that was what they had in the field. So, to conclude, you need to understand the basics of technical report writing. It is important. Again, I repeat, it is very important for any engineer. We need to always understand what our problem is, because when we understand what the problem is and when we solve it, we're able to communicate succinctly. Research, research, research in doing your job, in trying to, even after you've solved the problem and you're putting it to paper, research so that you're able to communicate effectively. That when people are reading your paper, it will be fluid. Distinguish yourself with the solution or method. That's actually the reason why you're writing this paper. If you're writing the paper about something somebody else has already written, there's actually no point. You should be writing something novel. It should be clear to everyone why, or anyone who's reading your paper, why he is reading your paper. What's new? Why exactly should I be? Why am I reading your paper when I've already read something else that addresses the problem? So it needs to be clear. And our advice that is captured in your abstract, because that's the hook. When people see it, they say, okay, this is what's new about this research and about this problem that has been solved. Be open to get help. Very important, guys. Be Socrates all the time, and let's try eliminate the Dunning-Kruger effect. And finally, always be open to learn, unlearn, and relearn. Thank you everybody for listening. Once again, we appreciate listening to us. We appreciate coming to the channel. We appreciate the comments, the likes, the shares, the subscriptions. Please, once again, do not forget to click on the subscribe button if you haven't. And thank you once again. We'll see you on the next topic. Bye for now.